As earlier we discussed about the what is the cleaning validation, what is the criteria for cleaning validation, and what is the process we are following for the cleaning validations activities, and what is the worst criteria for cleaning validations, and how we select the worst criteria based on cleaning validation study is, we have to calculate the MACO based on the therapeutical daily dose criteria, toxicological criteria, and health based, that is the PD criteria. So all the things we discussed, and we discussed about the solubility of the products. Those products are less soluble. The cleaning validation activity, and like same like PD value. So today we will discuss about the approaches, life cycle approach for the cleaning validations. Means what is the sampling, how the sampling perform for the cleaning validations, and assessment for the cleaning validation studies. So cleaning procedure should be designed with adequate assessment to provide the expected assurance of consistency and effective for the intended product and equipment. The cleaning process requires design and development prior to implementation in manufacturing plant in order to ensure the cleaning process and equipment are acceptable for use. So assessment is required. Design and assessment of equipment is very much important part for for use of that particular equipment in the manufacturing process. If design of the equipment is appropriate, then only we can use it appropriately. Otherwise, there may be chances of the microbial growth, and some other problem may occur due to inappropriate design of the equipment. Hence, whenever we perform the qualification of the equipment, first of all, we perform the design qualification. Means what it means? It means the design of the equipment should be as per our requirements. The cleaning procedure must be arrived while understanding the process, equipment design, and other factor collaboration with the various cross-functional teams, that is CFT team members such as R&D, production, and engineering teams. The objective to development the cleaning process which is to be adopted. This is was enough to clean the worst case residue to level below the cleaning limit, and that it should be the rough enough to that the case new products and chemicals their resulting residues are introduced into the facility. The existing cleaning procedure is still just as effective. Whatever the procedures we are having, it should be appropriate. The important elements is that the residue characteristics, selection of the cleaning agent, selection of the cleaning process variable, and justification for the criticality, and review equipment design and inspection procedure, determine the residue limit and overall acceptance criteria. So limit of residue is defined based on the worst case criteria, based on the MACO calculations. Selection of the analytical method, selection of the microbiological method, and define sampling method. So appropriate sampling method, direct or indirect sampling, which has have established the minimum accepted recovery should be used. Visual inspection means whenever we are going to collect the sample for cleaning validation studies, means we collect the sample for collect the sample, swab sample, or rinse sample. So first of all, we have to see the actual condition of the equipment, either it is appropriately cleaned or not. Means whenever we are going to collect the sample, the visual verification of the equipment is very much important. And if during visual inspections, if we found something in that particular equipment, it should the further sampling should not be performed till the appropriate cleaning of the equipments. The procedure shall have the adequate specific control parameters such as detergent cleaning agent consent. concentration, temperature, scrubbing, time and manual cleaning action, as well as the defined sequence of process steps. Adequate control also include specific detergent and cleaning tools such as brush and wipes. Means some cleaning accessories and aids we have to be used for appropriate cleaning of the equipments. Cleaning quality risk management. Uh, so we have to perform the risk management also. So for the cleaning method validations. So what are the critical component and key components we have to consider for the risk management? We'll discuss. So after design of the equipment cleaning procedure, a systematic quality risk assessment on the procedure before further step will help to achieve the robust control that yield consistent results given as below. The key component of risk assessment. Now here we are discussing about the FBD, fluidized bed dryer, how to perform the risk assessment for cleaning validation, cleaning procedure for FBD. So risk assessment tool selection is the FEM, failure mode effective analysis. There is one tools for investigations for risk assessments. So now that particular tools that is FMEA we are using for the investigation and risk assessment. This is the tools from the ICH guidelines, ICH Q9 quality risk management. So risk assessment tool system failure mode effective analysis is the preferred tools for performing the quality risk assessment, which will facilitate identification of the equipment of the possible location or residue possible, the level of dismantling required for the equipment parts, selection of the tools required to clean, and sequence of cleaning to be followed. So during that failure mode effective analysis, we identified all those the impacted and the calculation according to the failure mode effective analysis that is called severity, reproducible severity, and three calculations are there. So based on that RPN number, risk priority number, we will decided either that particular risk will be acceptable or not. If it is not acceptable, then we have to generate some mitigation plan to reduce that particular risk. And after the achieving that particular risk within the criteria, we will go for further investigations. So identification of the cross-functional teams. First of all, whenever we are going for any assessment, any risk assessment, we have to perform by the some functional teams. So means we have to identify some key persons, subject matter expert from the different departments or different person, those who are directly or indirectly involved in that particular activity. Like in that case of the FBD cleaning procedures, the FBD is available at the manufacturing area. So manufacturing person should have that part of investigation, and the quality person always perform the all those types of validation activities. So if quality person is required for that particular investigation, and engineering person is required for some maintenance activities if required during the execution and during the validation activity, and some technical operation also included, that is operation in the immediate of supervisor, maintenance engineer, IPQA team, means the person those who are directly contact with that particular activities, means the subject matter expert person should be part of that investigation or risk assessment, so that we can identify the risk, and based on that risk we can represent our the control measures. If we are having the appropriate control measures, then we can go further for the particular activity. So equipment description, purpose and functionality should be described. Equipment operation and cleaning procedure. So as in earlier sessions, we already discussed about the cleaning procedure, like some equipment having the cleaning procedure by manual activity and by automated activity. So automated cleaning activities performed for the, some dedicated equipments, and manual activity performed for the all types of equipments wherever the automatic cleaning procedure is not appropriate. The list of such category of equipment should be mandatory at the at site like FBD, equipment ID, MAC, design, functional drying, that is that is drying or top bottom spray, etc. Listening the major component and sub part should be available of the fluid bed dryer FBD for contact and non-contact parts, including inlet air and exhaust air vent. So, before understanding of that particular terminology, we should have to understand what is the FBD and what is the part of that particular FBD. So, uh, we have to just a minute. Just I would like to show the picture of the FBD that we can understand what is the uh, plenum, what is the regarding chambers, and where from the inlet air comes and exhaust airs out. So we would okay. So the locations and different location of the FBD is like inside the bowl, gasket bowl, inside the inside the retarding chamber top, between the screen and wall, view port, glass view, and SS, cleaning port, sampling port, discharge port, gasket ring near the drain ports. So these are the different location of the equipments, which is difficult to clean area. We can say that like so we have to collect the sample from that particular area. So it's also come under the that particular part we have to cover during the risk assessment by failure mode effective analysis. Okay, so this uh, so schematic diagram of the equipment should be available for easy understanding. As I would like to show the pictures of what it's not identified right now. In further slide, we will see that particular image also. Material and water pathway from where the water will reach to that particular equipment. And supporting document to perform the failure mode effective analysis is that original equipment manufacturer recommendations and review of the equipment manuals. Means we should have the manuals of that particular equipment during the investigation, during the and operation and cleaning procedure. So what is the SOPs we are having for operation of that particular equipment, and cleaning procedure should be available for the risk assessment, and photographs of the for that particular equipment and their component. QMS data. QMS data means quality management system documents like change control deviation, CAPA investigation. Some QMS data should be available. With that means earlier, if we are having some types of error or some changes we have done in that particular equipment. So all those things should be available during the failure mode effective analysis. And interview documents, so means the some subject matter expert are the part of that particular risk assessment. So whatever the discussion held with that particular persons, everything should be available during the risk assessment through the failure mode effective analysis. Identification of potential failure mode which may lead to contamination or cross contamination. So what we identify during the failure mode effective analysis, that what is the potential failures which may lead to the contamination or cross contaminations, and area which are difficult to visually inspect without dismantling. Means whenever we perform the cleaning, we open that particular equipment, that is called the dismantling of the equipment. So area which are difficult to visual inspect without dismantling is we have to be included in that particular parts, and in that particular times we have to be included, like in that case, if the that particular equipment and parts is difficult to visual cleaning without dismantling, means we should have the provision for dismantle of that equipment, and our procedure govern that we have to perform the dismantling of that particular equipment. Means we are having the current control measures, so we can accept that particular type of risk. Next is the identification of the powder adherence probability. Means the as we earlier sessions we discussed that the surface of the equipment should be smooth, and in that case, if the powder is adhered to that particular equipment, the risk is high of product contact surface, including the duct, drain, and lower planar. So component-wise risk assessment to identify the potential failure mode during failure mode effective analysis and recommendation of the risk for risk mitigations. Means we have to plan to reduce that particular risk. Risk management, pre-readiness for the conducting failure mode effective analysis. Gemba walk. Some Gemba walk, what it means somebody will come and ask something about that particular equipment. Means there may be some possibility of error or some technical issues. So that all those things should be covered in that particular failure mode effective analysis. So Gemba walk understand the assembling and dismantling of the equipments, view cleaning, and probably of deposition of the product residues. Means as we discussed, we should have the operational and cleaning procedure available during the preparation of the failure mode effective analysis. So what Gemba walks do? Gemba walks do that that particular SOP. They will ask to you that what is the procedure for the cleaning. If you are performing that particular cleaning by the referring of the SOP, and either that particular procedure is the feasible for this cleaning or not, they will understand, and based on the understanding and the some gaps, if they identify some gaps, they will acknowledge. And interview the soft floor persons conduct to understand the existing cleaning procedure and identify the action items for enhancement during the failure mode effective analysis, as we discussed in previous topics. So the OS related cleaning validation failure historical views, we have to review some historical data or previous data related to OS. Deviation, as I discussed here, that we should have the QMS documents. So during the that particular part, I already told you that we have to that times we have some OS and deviations we have to review. And what is the template of the failure mode effective analysis? So first of all, that we have to consider the component. Component means like if we are having the bowels of that particular equipment. So what is the bowels? So the component is the bowl, and sub part of that bowl. So some glass view panels are there. Sampling pot is there. That is part of that particular bowl also. So we should have the photographs. So based on the photographs, we can identify some gaps, and we can we should have some procedure according to that. Product context and non-context parts. So in that case, we have to identify that particular parts directly contact with the products or not. Failure mode means in that particular parts what the failures may occur. We are having the bowls and some mesh are used in the bottom of the bowls. That is the Dutch different types of mesh are used like Dutch mesh sieve and other sieves. So potential effect and failure, what failures may occur. So there may be chances of contaminations, and if cleaning is inappropriate, there may be chances of contaminations. Severity, how much possibilities of particular actions, particular parts may be applicable for that. So we have to include that particular part in failure mode effectiveness analysis. And rationales for severity rating. So we will give the numbers for severity. Suppose we are having the rating of 1, 2, 5, 1, 2, 3, 4, 5. So if it is the severity is more, then we have to give the number is 5. If it is the less severe, then we have to give the number 1. So the rational we should have why we are giving the number as 1, 2, 3, 4, 5, whatever. The potential cause of failures, what is the potential cause? We have to be identified the probabilities of occurrence. So there three things is important for the calculation of the RPM is RPN is severity and probability, and one is the detectability. So if it is more severe, then rating we have to be given like that. The probability of occurrence is more, then we have to give the number 1 to 5. So after the calculation, the RPN number, the number should not be more than the predefined limit. Why I am talking about the limit? Why? Because some guidelines means in case of ICS guidelines, they are having the different numbering procedure for different levels, means severity and rating levels is 1 to 5. So if it is low, moderate, high, or very low, very high, so 1, 2, 3, 4, 5 steps are there. And different organizations are having some very different levels also, means the level may be 1 to 7 also, 1 to 9 also. So in that case, then calculations is changed for that. So now we are talking about as per the ICS, the number should not more than 125 RPN. Means if severity is 1 and priority, if probability is 1 and detectability is 1, then our total RPN number will be 1. So based on that, we can conclude that we are having the all current control measures is available and is sufficient. If the number is more than the limit, then we have to plan the risk mitigation. So one more thing is there, the current process controls, means if we are having the procedure, and when our procedure we have introduced the introduced our controls. So its control, if current control is sufficient, then there is no requirement of any mitigation plan. So conclusion and final recommendation of failure mode effective analysis, as I told you that based on the all the assessments, we can conclude. So precious instructions for dismantling and cleaning subparts. Define type of cleaning aids, scrubber and scrubber brush, like that. And defining aids to conduct visual cleaning based on the component and part of the equipment, like torch light, and some cameras we are using for the verification of the cleaning, like in boroscopy. And if in case of boroscopy, we are using the camera systems for appropriate is boroscopic process. And exploring the engineering solution for the cleaning of the large surface or duct. Now now we should have the as I told you that we should have the operation and cleaning procedure. So how the cleaning are performing, so we should have the cleaning checklist. So based on that checklist, we will check all the checkpoints that that either that are applicable for that particular cleaning or not, or that particular activity actually we can perform or not. If we can perform that times we have to be recorded in that particular checklist. What times we are starting the cleaning, first of all, which parts we have to be dismantle, and which parts we have to clean by the purified water and potable water and some cleaning agents, and what process we are following. So so everything's come under that particular checklist, and then we have to identify the critical process parameters. Means what is the critical process parameters and critical quality attributes? So critical parameters in the case of cleaning validation is the process pressure, process flow, process time, cleaning agent concentration, dirty and clean equipment hold time. That are particulars are the cleaning process parameters. And critical quality attributes, what is the CQA, critical quality attribute? That is the product residue, cleaning agent residue, and visual detection or limits, microbiological residue limits, drying, conductivity, and resistibility. So now we are talking about the as in early sessions we discuss about the manual and cleaning methods. So what is the difference and advantage of that particular method? In case of automated method, cleaning is in place, and in manual cleaning method, cleaning is out place. And automated cleaning method is performed for the dedicated equipment, and manual cleaning process is followed for the non-dedicated equipments. Indirect product contact surface or product contact surface, directly we are performing the cleaning by manual. In case of automated, there is the low risk. In case of the manual cleaning, is the high risk for the location. There is the minor equipment, is the major equipments as manual cleaning we perform. And low risk drugs are used for the automated cleaning procedures, and manual cleaning is performed for the low risk, high risk drugs. Highly characterized residues, poorly characterized residues, and liquid formulations generally used, and solid formulation manual cleaning is performed. Easy to clean products, for easy to clean products we are using the automated cleaning procedures, and difficult to clean process we perform the manual cleaning. And materials which smooth and non-porous surface, means the surface of the equipment is the smooth, so we perform the automated cleaning. And porous materials or for non-smooth surface we perform the manual cleaning. Is the single product facilities, means each and every products after base to base changeover or product to product changeover, we are using that particular equipment for single product in the single facilities. Means if we are manufacturing the as in earlier sessions we also discussed that the separate units for the contraceptives and some antibiotics and some macrolides. So in that case, we can perform the automated cleaning facilities for that particular equipment. And if we are manufacturing the multiple product and we are having the facility for the manufacturing of the multiple products, in that case, we are maximum the companies are following the cleaning procedure by manual. Non-campaign products, and this is the campaigning products. So based on the above assessment, we can say that the different types of cleaning method can be developed, like cleaning in place, cleaning out place, manual cleaning, semi-automated cleaning, automated cleaning, solvent restricted cleaning, and placebo batch cleaning. So what is the cleaning in place? They refer automated systems which can be single pass or recirculatory system. It generally utilizes a spray device to provide coverage. The physical implement or equipment surface example are manufacturing tanks, blenders, fluid bed dryers, reactors, and fermentation tanks. Means this is the unit, means single single surface of the equipment is there, means like a bean and blenders and tanks. It's a single equipment, so we can clean it easily. So we can say that we can use the automated cleaning procedure for the cleaning is in place if manual. And now cleaning out of place system is the smaller equipment items or dismantled parts are transported to designated wash area. These are generally done manually, and hence a details procedure and appropriate training is required. It is important to ensure that the equipment is protected during the transfer in common corridors. Why? Because if we are having the dirty equipment and parts of the equipment is dirty, and we are going to bring that particular equipment in the different area where we have to wash that particular parts or dismantle parts of the equipment. So during the transportation, we should follow the appropriate handling of that open equipments by why it is required. If it is not appropriate, so there may be chances of contamination in the corridor. So we should follow the appropriate procedure for the transportation of that particular parts of the equipments during the transportation from the equipment area to the wash area. So what is the cleaning procedure? Manual cleaning procedure. These are the direct cleaning by the trained operator using the hand tools. Hand tools means what? So some cleaning aids and cleaning agents. Important cleaning parameters included. So what is the cleaning aids? We will discuss in further slide with the photographs also. So it will be easy to understand that what cleaning aids we are using for the cleaning of the particular equipments. So important cleaning parameters include the volume of the cleaning agents. Means if we are going to clean the some blender, so we have required the large volume of the water. And in some cases, if the hot and boiled water is required for cleaning, in that case also we should have the appropriate resources to provide the hot water in that particular area. Volume of rinse water, temperature of wash and rinse solutions, sequence and durations of soaking wash and rinse steps, scrubbing actions, pressure of solutions, detergent concentration, etc. So in case of manual cleaning is very much important that what temperature of the wash solutions and detergents we are using, and what pressures we are applying, scrubbing actions, and solution, whatever the solution detergent solutions we are using by spraying. So what is the concentration of that solution is also important part of manual cleaning. So it is important to the details instruction in the cleaning SOP that so during the cleaning validation, it is important to instruct in the cleaning procedure SOP that how much times we require to cleaning, which types of cleaning agent we have to be used, what is the scrubbing methods we have to be follow, what should be the pressure of the waters we are using, and what is the concentration of the detergent. Everything should be clearly mentioned in that particular SOP of the cleaning SOP of the equipment of respective equipments. And the person or operator, those who are directly involved in that particular cleaning activity, should be trained according to the procedure. CAT semi-automated process means these types of cleaning is the intermediate between the fully automated and fully manual cleaning procedure, where some parts can be cleaned manually or some parts can be automated cycle. Automated process does not involve and does not intervention of any manual process. Such as a process usually driven through the PLC or computer programs where the control system regulated the cleaning cycles. Addition of the cleaning agent, temperature, time, and other cleaning parameters. The cleaning of such a system is critical to surface of an automated cleaning process. Solvent reflux cleaning. This is appropriate for small molecules of API manufactured or organic synthesis where involve boiling with the volatile solvent in a reactor vessels. Means it's for the small volume. And placebo batch as cleaning method. In some cases, if we, uh, we would like to clean the equipment by the placebo method, means we have to perform the process by the batch without the API, that is called the placebo batch. So by the performing of that particular activities, we can clean that particular equipment appropriately. Like for highly viscous ointment and products or potent hazardous products, it may be feasible to use the placebo run as method of the cleaning equipment, and the approach required the use of placebo that has no determinants effect on the next manufacturing product in the equipment. The disadvantage including the cost of cleaning and difficult in demonstrating the effectiveness of the process. Why? Because if you will take the full batch without the API, it also cost for the excipient, so it's costly process, so it's generally avoided. But in some cases, like in case of ointment products, they need to be performed the cleaning by the placebo batch also. For manual cleaning process consistency shall be controlled by the adequate specification, actions, written cleaning procedure by training operators and identifying important steps which needed supervision during the cleaning operations. Wherever manual cleaning procedure is not adopted, it is recommended that the cleaning procedure is developed by performing the failure mode effective analysis. As we discussed, there are some components we have to include: severity, probability, and detectability, and we have to mention our current control measures. And if the risk RPN number, risk priority number, are within the limit, then it's acceptable. Otherwise, we have to reduce that particular risk. So, based on the outcomes of the failure mode effective analysis, we have to determine the following things: the level of dismantling to be done, identify hazards, cleaning surface, logical steps for cleaning, type of cleaning aids to be used, important steps which need supervisions, type of sampling aids, and type of visual inspection aids. So now uh, we'll see the typical cleaning process that have the following steps, like vacuum and pre-rinse. Means once we are following the vacuum and pre-rinse, means functionally removal of ready soluble and non-adherable residues. Comment what is that reduction in the residue load prior to washing. Means if we pre-rinse of that particular equipment, so reduction in the residue load. Washing with the cleaning agents. So, what is the function of that particular cleaning agent? Is the removal of soluble and dried residues, solubilizing residue by wetting with the detergent, degradations, or heat. So, what will be the happen primarily to remove the residues or bioburden, often done at the evaluated temperature. Use of detergent, alkali hydroxide or acid, or combination of the solvent or solvent mixtures. And what is the rinse? Rinse is the removal of the suspended or solubilized residue and cleaning agent as applicable. May include series of rinse and final rinse with higher grade of rinse solvent. And now dry, removal of water and other solvent by the drying procedure and may done by the air or nitrogen flow or by heat. So there are different way of drying may be followed. Best cleaning process qualification. So identify the worst case of the products. As earlier we discussed, how we identify the worst case product. So we identify the worst case product by the solubility of that particular products and PD value of products, 10 ppm criteria, theoretical daily dose of that criteria, toxicological data criteria, and also visual inspection of the equipments. And qualify equipment, reviewing the utility, readiness, cleaning SOP, qualified cleaning agent suppliers, analytical methods, sampling plan, justification, number of qualification runs, cleaning qualification protocols, training of the personals, everything whatever we have discussed should be evaluated during the cleaning. So worst case product selection. How to select, as earlier I told you that we have to prepare the list of that particular products like that. We are having the tablets of different products. Ingredients are part of that. In that particular parts, some ingredients are soluble, insoluble, and the quantity in kg of the base size of that particular batch. So total insoluble material in batch is like that. So we have to tabulate all those details of the batches. And one more thing is that example of worst case approach means like, okay, again. So we have to prepare the list of the products for the worst case criteria calculation. So what is the products? What is the API of that particular products? What is the strength of the products? And what is the pharmacological action of that particular product? Type of formulation, either it's coated, uncoated, tablet, imprinted tablets, and capsules. And what is the base size? Batch number is not necessary for the calculation of that particular batch, for but for identification of that particular batches, BMR number is also important for that. The ration for the ratio of the base size, API solubility, PDA value, and total quantity of the insoluble components. So based on that criteria, we select the worst case criteria of the product. So there are so many calculations. So means there are different types of calculations we are using for the macro calculation. Maximum allowable carry overs. So different calculations, different type of activities we are following for the daily dose criteria, like based on the therapeutic daily dose criteria, then macro calculation. So in that case, the formula is the TDD in MBS, SAF and TDD is something, is what is it? It's something part of the calculations. So when we'll discuss about the calculation part, so we'll discuss more about the macro calculation part and the solubility criteria. That is, the solubility is different categories. Very soluble, freely soluble, soluble, springly soluble, slightly soluble, very slightly soluble, insoluble. What is the very soluble means less than one part is soluble, then it's called a very soluble. Freely soluble from 1 to 10 parts is soluble in part of volume, that is called soluble. If more than 10,000 parts is not soluble, then it's called insoluble. And this is the PD value criteria. That is the smallest therapeutical dose. Those criteria, that is the less than sorry greater than 250 micrograms, more than 50 to 250, more than 5 to 50, more than 1 to 5, up to 1 micrograms. So AD and PD data are not available. If the data for PD is not available, the other pharmacological dose, OEL and LD50 may be used. LD50 criteria, so PD value and AD value. Now we will discuss about the ads of ads used for the cleaning. One, okay. So now we'll discuss how to where from we have to collect the sample and what is the rationale behind the date. So swab sampling, direct surface sampling. Now we have discussed about the equipment and their location and the worst case criteria, how to select the worst case products, and everything we have to select it now from and how we have to collect the sample. So what is the swab sample, what is the rinse sample, why where from we collect the swab sample, and how much quantity, how much surface area we should have to consider for the swab sampling, and for rinse sampling where we have to perform the rinse sampling, everything we'll discuss in further. So swab sampling of the direct surface is designed to the test small section of the equipment's surface. Means generally industries are following the 3 by 3 centimeter square area or 9 by 9 centimeter square areas they are using for the calculation of the swab area. So we should have the template for collection of the swab from the surface of the equipment for easy calculations. So swabbing irregular surface. If the equipment swabbing is not possible or fail surface due to the equipment design, the equipment area should be swabbed. If swabbed area available is smaller than the dedicated area, as I told you that we should have the template for 3 by 3 centimeter square, and if the part of equipment is less than that, then that times we have to consider the complete area for swab. Rationale for selection of swab method when performed for rinse sampling. So swab sampling is preferred method for swabbing is direct surface sampling method, while rinsing is indirect method. If we are having the surface to collect the sample, then we'll perform the swab sampling. If the surface sampling method, while rinsing is indirect method. Swabbing is indirect surface. Okay. So by the swabbing sampling area that hardest to clean, which are reasonably associated can be evaluated. Additional residue that are the insoluble can be sampled by physical removal. However, rinse sample involves sampling equipment by rinsing the solvent over all the relevant equipment surface or removal residues which are then measured in the rinse solvent. Rinse is more suitable for the pipes, as I told you that where is the rinse sample is applicable. So rinse is more suitable for the pipes, longer tubes and larger tanks with connecting walls, in short place that are not easily reachable. If we are not reachable for the collection of the swab, that times we will perform the rinse sample. The use of swab is critical in determining the contamination level found in imperfection in products equipment such as rough surface, weld point, cavities, or in the places where general rinsing will not be easily contact the equipment surface. So from where we perform the start to perform the swab area, so we are having some defined area that is 3 by 3 and 4 by 4. So we have to perform the sampling by the swab sticks by horizontal and vertical motions. So we have to start from the left top corner to right bottom corners in zigzag way, or in some cases we, as mentioned in the picture, we collect the sample in like zigzag way. One is for horizontal and one is for verticals directions. So swab side means if whatever the swab sticks we are using, if swab stick is in the flat shape, so once we have to collect the sample by the one side for that particular locations, and for second side for different directions. And this is the template. So as we discussed that we should have the defined area for the area of the equipment for collecting of the swabs. So that particular design of template should be there. That is like that. So we can consider we can conclude that particular parts. So we can perform the sampling by the appropriate method, that is for horizontal and vertical. So different types of templates we can use, and this is the swab sticks with the test tube. So type of swab. So swab and swab material should be convenient and easy to use, able to take residue from coupon and equip the surface, able to release residue into the solution, not cause any interference with the residue. So the swab sticks material should not be react with the residue of that particular part, that particular solution samples. So made of material that do not shed particles, wooden sticks must not be used. So different types of sticks we are using. As this part I already told you that what is the location of the equipment, and this is the whole picture of the FBD fluidized bed dryer. So this is the retarding chambers. Though this particular part's whole body is called the retarding chambers, and this is the outer side of the retarding chambers. And if we see the inside, that we can say that the inside retarding chamber, then that is the charging port. So if you would like to charge some material into the that particular FBD by the PTS system, power transfer system, then that time so we can use that particular port. Otherwise, we can directly load the material in the bowl, and we can put it means we can dismantle that particular bowl and can transfer the material into the bowl, and then can fix into that. And this is the glass view panel to see the material inside the FBD bowls. Means we can see the fluidization of that particular equipment, and if some lumps of the products is observed, then we can check it from here. So this is the glass view panel of the equipment, and this is the bowl. And this part is there is one part is called sampling ports. So the different critical parts. This is the inside of the retarding chamber. This is the glass view panels, and this is the retarding chamber inside part, and this is the gas for port, sampling port. So all those pictures are from where we collect the sample. This is the inside of the bowl. Okay, and this is the plenum. This is the plenum of the FBD. So from there the inlet air comes, and this is the inside duct after flap. So in that picture there is some flap. In the second picture, flap is open. Some inside nozzles are available. Okay, and now this is the swab sticks. So generally, tax wipe swab sticks are used in most of the pharma industries. It's also approved by the FDA. Also, FDA is also recommend that the tax wipe is better for collecting of the swab. So remaining part we will discuss in next sessions. Can we close that particular session here only?
Yes, sir.
Okay. Thank you all.
Okay, thank you, sir.